Okay, we're gonna work some problems. Now, you do realize on Canvas, I'm putting the YouTube video link on Canvas for you, okay? I don't know if it's any better than the WebEx link, but it works for me a lot better. It records every time, where the other one doesn't. Okay, so we've got problem 5/119, okay? So what we've got here is a part, okay? It's like made of two different metals, okay? We've got a part that's bronze and a part that's steel, okay? To me, it kind of looks like a steel bearing holder on a bronze shaft. I mean, I don't know why you would do it in that direction, but that's the direction they give it to us, okay? So, we've got a bronze bushing mounted inside a steel sleeve. Knowing that the specific weight of bronze is 0.318 pounds per cubic inch and steel is 0.284 pounds per cubic inch, determine the location of the center of gravity of the assembly, okay? Now we're going to assume with this assembly that it is symmetrical, okay? Which means that it has uniform measurements, and it also allows us to assume that we have three separate parts, okay? And of the three separate parts, we're gonna assume the bottom of the cylinder, the upper parts of the cylinder, and the inside of the cylinder, okay? Makes life a little bit simpler for us, okay? If we were to change this bottom piece up and make it a square or an octagon, we could still make those calculations. It would just be a little bit harder, okay? So, we're gonna call this, I'm gonna slide this up so I've got a little bit more room to write. Is that okay right there? Yeah. Can everybody see all the information we need? So, I've got part 1, part 2, and part 3, okay? Now, with those, they're all on the same XY coordinate system, right? Coordinate axes, agree?
Mm-hmm.
Yes? So really, we're just looking for the Y location, right? Because what's the X location?
Dead center.
Dead center, which is X equal to
0.
0, okay? So since it's a uniform part, it's gonna lie along that X origin, okay? Origin at 0, okay? And we're gonna be looking at where it is from here to here. So we need some information, okay? We need some information. We need the center of gravity for part 1, the center of gravity for part 2, and the center of gravity for part 3, and then we can find where they are with respect to one another. Now, I'm gonna kind of throw back something to you, okay? Maybe bring something back from chemistry. Okay, I know we didn't like chemistry, but I love chemistry. But when we look at the periodic table, we look at atomic weights. What are atomic weights?
Rate of a mole.
Let's not get that specific. They're a weighted average of all of the isotopes that make up an element, right?
Mm-hmm.
So like for hydrogen, there's 3 main isotopes: hydrogen 1, hydrogen 2, hydrogen 3. And the abundance of hydrogen 1, hydrogen 2, hydrogen 3 determines the atomic weight that's on the periodic table, which is 1.00794, which means which one's in greatest abundance?
Hydrogen 1.
Hydrogen 1. Okay, we've got 3 parts here. Okay? Would you not agree that this is a weighted distribution based on which parts have the greatest amount of weight? If we're looking for the center of gravity, what is the center of gravity? The center of weight, right? Agree? It's just like a weighted average, except we're not taking an average, we're taking a location, okay? So, how can we find where 1 is? Where the center of gravity for 1 is, or the mass at the center of gravity of 1? Well, let's look at 1. What are the dimensions of 1?
0.4 high.
0.4 and
1.8.
1.8 inches, okay? We're not looking for X, we're looking for the Y. So where is that gonna be?
20.
It's gonna be half this distance here, 0.2, right? So Y1 is gonna be 0.2 inches, okay? Times what? Well, this is steel, okay? A bronze bushing is mounted inside a steel sleeve, so bronze is the brown, steel is the bluish color, okay? So what's the density of steel? 0.284 pounds per cubic inch. Now, if we multiply that, we're gonna get pounds per square inch. And we're really looking for pounds, because we're looking at the distribution there. So what do we have to multiply by? We have to multiply by the area, right? Because the area would get rid of these square inches, right? So what's the area of a cylinder?
Area is pi r squared.
Wait, what, I
That's
thought
a
it
circle.
would be area of a rectangle?
Okay,
This is all cylindrical thing.
the whole thing is cylindrical. The whole bottom is a cylinder. It's a circle, and then a circle on the inside to make it symmetrical. If it was, it could work as a square, length times width, but it's not, because I told you it was a cylinder. Okay? That's the only reason I told you it was a cylinder. So what is that?
We're gonna have to do a big calculation and remove the bonds from the equation, aren't we?
Well, a cylinder. That's the volume, right? Agree?
Yeah, and the base is going to be pi r squared because we are multiplying by our.
That's what the volume is, right? So if we're looking for the area, what did you say? You said it, but you didn't say it right. You said
Pi r squared.
Pi r squared. So the area. Okay. Now, what's special about the area of this bottom? It's this entire area minus what?
The bronze area.
The brown colored area, right?
Mhm.
Agree? So it would be pi times r. What's r?
0.9 inches. It's half of the diameter.
Are you sure?
Yeah.
How about this?
That would work too.
Why? I just told you. What did I tell you? I've got the whole part minus the inside, right? Now your thinking was the whole part.
Yeah, and I was going
Right.
to minus the area of the inside.
Oh, you were gonna minus it later. Okay, that's good, but just make our equation longer, right?
Yeah, that would.
Okay, now times what? Times what?
That's squared. Your height.
I didn't plug in my height. What did I plug in?
Your y.
My y. Okay? So I multiply this through. Okay? I multiply this through. What do I get? Some number of pounds. Okay? I get some number of pounds.
0.2.
A small number of pounds, right? We forgot to square this here. Okay. So how many pounds do you get? Like 0 point something? How do I know I get 0 point something? What do I start with my number here? 0.2. Okay? So
0.0208.
Can you give me another digit?
It was 0208.
I'm sorry, you said that. I 0208
8.
even.
That rounds, it's just 8.
Okay. Now what would be YT for part 2? What would be part 2? Okay, we would have what? The height for part 2. Where is the height for part 2?
1 inch, so half of that's 0.5.
0.5 should be here in the center. But what is the distance that we would use?
Add.
Where is that 0.5?
In the center.
It's 4/10 above the 0, right? So what would it be?
0.9.
0.9. Now it's still. Oh, that's pretty good. It's still. Right, didn't get that. Okay, 0.284 pounds per cubic inch times. Now, what do we plug here? The same
Same
thing.
thing.
Pi times. Now, what's the diameter?
Diameter is going to be 1.125 minus 0.75.
Minus 0.75, but we're really looking for the radius, right? So we divide that by 2 and square it times what?
0.9
1 inch.
times 1 inch, right? Oh, this side, yeah.
Because that's the total length of it, right? 1 inch. So how many pounds do we get?
.9 times 0.284 times
I bet it's 0 point something.
times 1.1.
Because the only number greater than 1 is 1. Right?
Zero point 0282.
You sure?
That's what I got when I plugged it in to the calculator.
0.56.
I didn't do either one of those numbers.
Yeah.
I got 0.
0.0089.
I got 0.1568. So let's do it again. So it is
0.9 times
0.9 times 0.284 times 3.14. It equals. Then divide by 4.
Wait, divide by 4?
2 squared is 4, right? Times 0.375. Is that right? 0.375? 0.25 plus 12? Okay, what'd you get?
0.0282.
I didn't get it.
Okay.
I just-
I will do it again. And it's not to say that I did not mess up whenever I did it.
Got 0.443.
How about I plug this in? Okay, 0.9 times 0.284 is equal to 0.2556 times 3.14, okay? Divided by 4 times 0.375.
Is the 0.375 squared?
times 0.375. 0.0282. 0282 pounds. Okay? That's what so we got that. I messed it up on my problem, okay? Now, what about Y3? What is Y3? It's for the
Copper, well,
bronze.
bronze, whatever.
Okay, what is bronze?
Copper and tin, I think.
Okay, copper and tin, okay. And depending on the amount of copper and the amount of tin gives you the type of bronze you got,
Yeah.
right? Okay. Now, we know that this number right here is gonna change, right?
Mhm.
And it's gonna change to
Point
318 pounds per cubic inch. Now, what is this number here? What is that number there? What is the total Y height of that bronze
One
bushel?
1.4, so that's gonna give us
1 plus
0.7.
0.4, so it's gonna give us 0.7 times what? Pi times what?
0.75 minus 0.5.
Over 2 squared times what?
1.4.
1.4.
Point 7 times pi times 0.25 divided by 4, 0.25 squared. Y3 equals 0.0153 pounds. 0.0153.
Somebody else get that? Okay, now. Okay, what are these?
That's your weights.
The center of mass or center of gravity for each individual part, right? Agree?
Yeah.
Does everybody agree with that? Okay, so if that is the case, we know what? Y times the sum of the weights is equal to the sum of yi. Right? Don't we know that relationship? Okay, so couldn't we set this equal and solve for this? Okay, so how do we do that? Well, what's here? We'll start with the first one. 0.2 times what?
Times
0.0208, right? Plus 0.9 times
0.0282 plus 0.7 times 0.0153
and if we divide that by the sum of the weights, which is 0.0208 pounds plus 0.0282 pounds plus 0.0153 pounds, that would make this equal to Y bar. have to trust y'all's numbers. Obviously, I used the wrong calculator this morning doing this. Or maybe I shouldn't have been watching YouTube videos while I was doing it, right? Maybe that's probably it, yeah. I bet it falls somewhere in this area right here.
It's pretty good, I guess.
Yeah. Wouldn't be in the bottom, wouldn't be at the top, be somewhere in the middle, right?
I got 0.626.
0.0.
No, it's 0.626. That was right.
0.626, yep.
Which is about right here. Okay, about 0.26 inches above this, about a quarter of the way up there. Okay, so that will be the center of gravity, the center of weight. Okay, for that one. Okay, now in your book or somewhere in your brain, you need to know the volume of a cylinder, the area of a cylinder, the volume of a rectangular piece, the area of a rectangular piece, the volume of a triangle, area of a triangle. Okay? You need to know that. I mean, those are the ones that you need to know. If you have another one, I'm not intending to give you an ellipsoid or something like that. If you have that, I will give you the formula for the volume. But you need to know those three because those are the common three that you're going to be using. Okay? And the book has it. Just maybe mark the page that you can find it in the book. Okay? Questions on this one? Okay. Can I erase it? Has everybody got it before I move to the next one? Okay, locate the centroid of the plane area shown. That is number 5.137. Now, based on calculations, I will say some of the answers in the book are slightly different than what we calculate. They have the same crappy calculator I have, I guess. Okay? How can we approach this one? How can we approach this one to make it simple? Simpler.
Triangle and square.
Make a triangle and a square. So we could do that, right? So find the centroid of the bottom, centroid of the top. Okay, so what's the area of a square? Length times width, right? What's the area of a triangle?
One half base on the
1/2 base times the height. Okay, can we find out any other information here? We know we have in our book, okay, formulas to find X bar and Y bar locations. So if we've got a square, where's the X bar? Or if we got a square shaped object at that what? Midpoint, right?
Mhm.
So what's the midpoint here to here for the square?
3.
3. But it's from this point right here, which is what?
6 away from that, so that's gonna be at 9.
9. Okay, so let's make a chart here. Okay, so the area is equal to for the square. Length times width, what's the area? What's the area?
going to be
What's 6 times 3? 18, okay. For the triangle, what's the area?
1/2 base
Based
times
on the
height.
height, so it's 6 and,
And 12, so 6 times 6 is 36.
or 6 times 12 is 72 divided by 2, it's 36, so. Okay, then we got X bar, and we've got Y bar, then we have some other information we're gonna look for. Okay, what's X bar for the square shaped portion? We just said
3. No, 9.
9. Okay, what's X bar for the triangle? The length over 3, so what's the length?
12
12 divided by 3 would be 4. Okay, straight from the book, right? Straight from the chart in the book. Okay, now, what's Y bar? For the square.
Y bar is going to be
Half of 3, right? Which is 1.5 plus
Plus
6, so it would be
7.5.
7.5. For the triangle, what would it be? What's Y bar?
guess half your
base.
3 plus 3 is 6.
It's the same as X bar, which was what?
length times
6 over 3.
Well, the same relationship's what I'm saying, the same relationship.
6 over 3 is 2.
Is it 2?
6 over 3. Right?
Okay, wait a second, we get 12 here. What's the, look in your book, what's the Y bar location? Open that up to that chart in the book, open it up to that chart in the book. If X bar is the long side, what's the Y bar?
Short side.
The short side, okay, what's the short side for Y bar?
6 divided by 3 is
Is that the chart, what the chart says?
is it half. Did you say half earlier? You said
Did you say half? I didn't hear you say half.
At first I said half and then
I didn't hear that, I'm sorry. What is it, Mr. Allen?
half.
It's half, so what, half of 6 would be 3. Okay, now, what else can we do? We can have X bar times area. We can have Y bar times area. And that allows us to do what? Rearrange our equations. X bar times the sum of our areas is equal to the sum of X. Right? Yes? And now we're do what we just did in the problem before and find the central point, right? So, if we have these, we can do it this way. We can just multiply, right? So we can just start with X bar. X bar is equal to all of this X times A, the sum of them, right? Agree? So let's just do it. 9 times 18 plus 4 times 36, right? Divided by what? The sum of the areas. What's the sum of the areas? 18 plus 36. What's Y bar? It's 7.5 times 18. Plus 3 times 36. Over what? 18 plus 36. So we get an X bar and we get a Y bar. Okay? You need that chart. You need to use that chart. You need to have that chart where you have access to it in the book. what on a number?
X bar is 5.667 and Y bar is 4.500.
Okay, questions on that one? That one wasn't bad at all. After we realized the Stringfellow came here and y'all weren't looking at the book. You were just shooting it out there, okay? That chart's important. Chart's really important. Okay, everybody got that one? Okay. The last one, okay. Determine the reactions that the beam supports for the given loadings. Okay, so how can we do that? How can we approach that? Okay, I'm gonna do a little bit of, no I'm not, no I'm not. What are the reactions? What are the reactions?
A and B.
A and B, okay? Or the reaction at A and the reaction at B. So how can we find the reaction at A and the reaction at B? We can break it into what? Or we can break it into parts again, right? Yes, we have, let's see, we have from here to here, we have uniform, right? Okay, so the reaction there is gonna be 200, bless you, pounds per foot times 15 foot. Okay, so that's gonna give us a reaction of 3,000 pounds, right? For that rectangular portion. So this would be R1. Now R2 would be out here,
Okay, so let's work on
which is not uniform. It is what? It's a triangle, okay? But it's constant. It's dispersed constantly, right? So R2 is gonna be 1/2 times 6 times the 200
Hold on.
pounds per foot.
200 pounds. Foot.
So that would be what? £600. So R2 would be equal to 600 pounds. Now, can we find the reactions at A and B?
How did you get 15?
9 plus 6.
6 plus 9?
Oh,
That is 15, right?
Yeah.
I think so. Okay?
okay.
5.
5, 10,
6.
15. Yeah. Yeah. Okay? Now, could we say that the sum of the moments around A are equal to something?
Yes.
What are they equal to?
0 because it's static.
Okay, but what else are they equal to?
R1 foot times your distance plus R2 times your distance.
Is there anything else that they can be equal, that would be included in there?
The B force?
The B force times the total distance, right? Now, we want to assign positive and negative so that we start, right? In the correct way. So if we want it to go in this direction, we've got to make that positive, right? Counterclockwise would be positive. Okay, R1, what direction is it gonna push you? Clockwise or counterclockwise from A?
Straight on top of there, ain't it?
Say what?
It's the counterclockwise.
Counterclockwise, so that's gonna be a negative 3,000 pounds. Now, what's the distance?
Wait, push it. If you put it up here, it's gonna go.
What's the distance? It'd be concentrated where? At the midpoint there, right? What is the midpoint between 0 and 15?
7.5.
7.5 feet. Where is the support at?
6.
6, so where's it gonna be? What's the distance from the support? 1.5 feet. Now, I'm gonna put a plus there. R2, what type of rotation does it cause?
Clockwise?
Clockwise, so it's gonna be a negative 600 pounds. What's the distance? Well, it's gonna be 9 foot to here. And what do we know from our book chart?
1/3.
1/3, so 6 divided by 3 would be 2, so 9 plus 2, so it would be 11 foot. Plus, now, what do we know about B? We have no idea. What's the distance?
9 foot plus 6 foot.
9 foot plus 6 foot, so it's
15 foot.
15 foot. Now, we do know that B is pushing it or causing the rotation in what direction?
Counter.
Counterclockwise.
So this is gonna be a positive value, right? So, if we set that equal to 0, can we find B?
We can.
Yes. So, 3,000 times 1.5 is 4,500, right? Foot pounds. We move it across, that makes it positive. 600 times 11 is 6,600. Is that right? Make that positive. Is equal to B and all that divided by 15 foot.
740?
740. Okay, so B is 740. Do we have anything else we need to find?
A?
A. Okay, how can we go about finding A? How can we go about finding A?
Pretty much similar concept, except
We could do the moments, or we could do what?
Forces.
Some of the forces in the
Y.
Y direction would be equal to 0. Okay, so what are the sum of the forces? We have what? A pushing up, right? Plus B, which is 740 pounds, plus what?
negative 3,000.
Negative 3,000 pounds, because it's pushing down, plus a negative 600 pounds, because it's also pushing down, right? So 740 plus 360,
But no, that's 36.
oh, 3,600, sorry, yeah. I was thinking that don't sound right, but okay, so 3,600 and 740, that'd be 140 from that, so it'd be 2,860.
2860 is equal to
Okay, so we've got A, we've got B. What we're looking for?
a reaction forces. that's
Reactions
it.
that B supports, that's what we're looking for, okay? So we've got everything, we've got it all answered, okay? Now, you're thinking, Stringfellow, your test questions are not gonna be that easy. Yes, they're gonna be that easy. All you gotta do is make sure you understand what the test question is asking.